Welcome to today's GATE video. My name is I'm Sathya Priya, working as an Associate Professor in Department of Computer Science and Engineering in ENGG.COLLEGE. Now we are going to discuss about the topic called recursion. So here, before we get inside the topic of recursion, we will discuss about the function. Basically, recursion is a function. So we will discuss about function, then we will move to the recursion, and we will also discuss about the gate problems. Introduction to function. So function is actually a reusable block of code that performs a specific task. So it will be executed only when it is called, and it may take input parameter, or it may not also take input parameter and may or may not return an output. The advantages of this function is that it helps in modular programming. It makes the code modular and it avoids repetition of the code, since we can call the same code again and again by making a function call, and it improves the readability, and also we can able to maintain the code. The syntax for function is, so this is the syntax. Here we have the return type, function name, the parameter list. So here the parameter list, it can be an empty list. Either you can pass a parameter or you may not pass a parameter. The function name should follow the naming rule of a variable. The return value, if we are specifying any return type apart from void, if you are going to return any value mean, we have to specify the respective return type there. We will have an example here. Function definition. So for this, here in this example, I have defined the return type as an integer value. This is a function add, which will take two parameters of integer a and integer b. Here what we are doing is, it will return the value of a plus b. A is also an integer, b is also an integer. So it will return a plus b, which is also going to be an integer. Since we are returning an integer, whenever I call this function, there should exist a variable with an integer value, since this function is going to return an integer value x. So the return value has to be stored in some variable name called x. This is how the function works actually. Now we will get inside this recursion. What is recursion? Recursion is a function which is calling itself, which is called by itself. Actually, we will split the problem into smaller subproblem of same type. Here it breaks down the problem into smaller subproblems of same type and continues calling itself until the stopping condition. The main thing here we have to note is the recursive function must have two conditions. One is the base condition, the other one is the recursive condition. Here the base condition, which will specify the stopping condition, which will specify the stopping function of the recursion, and the recursive function will be calling the same function again. That is why it is called as recursion. Here it is helpful in the problems like the factorial problem, finding the Fibonacci series, and for tree traversal algorithms we will apply this recursion. Here the advantages of recursion. Advantages of recursion is, it is simpler. Since we are calling the function again and again, we are making it makes the code smaller and it makes the code simple. It provides better readability and it breaks down the problem into smaller subproblems of same type. Here it is useful for actually the hierarchical data structures like tree traversal, factorial and Fibonacci series. The disadvantages of this recursion is, it requires high memory usage. Since we are making use of stacked data structure, whenever a function is called, we will make use of stack. So the stack, whenever a function is called, it pushes the address, return address from where it has to continue from the main program, and it calls the function. After it returns from the function, it will be continuing from the main program. So it makes use of stack data structures. So it requires high memory usage, since the stack is built until the stack is maintained until the function call completes, as the function calls itself many number of times until the stopping condition is reached. Here the slower execution, because we are storing it in a stack, there may be a chance of stack overflow. Since the stack will be of small size, if the function is going to be a complex recursive function, then the stack overflow may exist. So it is also difficult to debug, since we are writing the code that calls by itself, or the function which will be calling itself, which will make the code little bit complex, which may feel difficult to understand the problem. Here, for example, we will have an example of finding the factorial integer factorial of n. We are going to find the n factorial. Here we are going to find the 5 factorial. Here, as I have already introduced, if n is equal to 0 or n is equal to 1, it will be returning 1. Everyone knows that n is equal to 0. 0 factorial is 1, and also 1 factorial is 1. So it returns the value 1. Otherwise, what we are doing, we are calling, this is what we refer it as the recursive function. Why it is recursion? The name of the function is factorial, and the calling here, we are also calling the function, recursion function called factorial of n minus n into factorial of n minus 1. Here in this we will be calling, so since the function calls itself, in this one we refer it as recursive call. Here we are going to find the recursion of finding the factorial of 5. We will have the tracing of this recursion call. What is the function call? So actually the function call is, if n is equal to 0 or n is equal to 1, it will return 1. Otherwise, what we have to do? We have to continue the same function by n into n minus 1 factorial of n minus 1. That is what we referred. Here we are causing the value of 5. So 5 into n into factorial of n minus 1, n is 5, n minus 1 is 4. So it will be calling the n for finding this factorial of 4. Once again it makes a call. Once again it checks whether 4 is equal to 0 here. So it is, n is not 0, it is 4, and it is also not equal to 1. So it moves to the else condition. Now it returns n into factorial of n minus 1, which is 4 into factorial of 4 minus 1. So here this is how the recursion proceeds. So 4 into factorial of n minus 1, which is 3. So now to find the factorial of 3, we will make, so once again it is not equal to 0 and it is also not equal to 1. So it will be continue with 3 in n into else case will be followed, 3 into factorial of n minus 1, which is 2. Here once again we don't know, it will check whether it is equal to 0 or 1. So it is not equal to 0 and it is also not equal to 1. So it will call, then it will call the factorial of 2. Now it will be here also the value will be is not, n is not equal to 0 and also not equal to 1. What it will be doing now, once again it will be making use of 2 into factorial of n minus 1, which is 1. Now the condition meets here. Since n has become 1, it returns the value of 1 here. So here factorial of 1, it will return the value of 1. So after it returns the value of 1, it will be popping out here. So and it will be 2 into 1 will be calculated. So the factorial of 2 is now 2, which is substituted in this function. The factorial of 2 is 2 here. So what it will do? 2 into 3. which will find the factorial of 3. Factorial of 3 is 3 into that factorial of 2 as we have calculated earlier. The 2 will be there, 3 into 6 is 3 into 2 is 6. Now once again this is factorial of 3. The 3 will be substituted here, and the, after substituting the factorial value of 6 here, 4 into 6 is 24. It will be calculated. So once again it pops off the 24, and it will be calling the base function, which is the first call which we made. So here we will be having 5 into factorial of n minus 1, which is the factorial of 4. So factorial of 4, as we have calculated, you will be having the value of 24. 5 into 24, 120 will be returned to the main function, and it will be printed. So this is how the recursion will be working. Okay, are you clear with this concept? So now we will move to the gate quotients, the base gate quotients. Question 1, what is the output of the following code? The array of 1, 2, 3, 4, 5, 6 is an array. ARR is an array which is being given, and the value of n is the number of elements in the array is 6. So and this is the function which is given in the question, and we are having these are the options. How we are going to calculate it? We are going to calculate it using this is an recursive function. Since it is calling the function, within the function we are having an recursive call. So it is an recursive function. Here we will have how we will calculate. What is the function here? The function is if n is less than or equal to 0 means it will return 0. Otherwise we are finding the function of, we are calling it with the array of n minus 1 plus array of n minus 1. What is this array? Array is a pointer variable. So we will be, whenever in C program to pass an array as a function, array value to a function, we will be passing the pointer, that is the starting address of the array will be passed to the function. So here the starting address, that is 0. Always the array index will start at 0. Here 1 is at the index 0. So the address of 1 will be sent to the function called n minus 1. What is n? N is the number of value, which is 6. So 6 will be passed here. That is 6 minus 1, 5 will be passed here. So this is what we are doing here. So this is actually the recursive function which is being called. Here the array value n is 6. So n minus 1, we are making a function call of function array of n minus 1 plus array of n minus 1. So function, this is a recursive call, and this is the element value which we are going to find. Here n minus 1 the value is 6, number n is 6. Here we have array of 5. N minus 1 is 6 minus 1, which is 5. Here the array of array comma 5 will be passed here. So next we have since this is a function which has to be called again, what we will be doing now, once again it will be making the call to the function. It will check whether n is less than or equal to 0. It is not less than or equal to 0. It is 4 here. So what it will do, once again it will call the function 4. So it will call the function 4 array comma 4 minus 1, that is already it is 4. So n is 5. So n minus 1 is 4. So 4 plus array of 4 will be that. So this 5 comes from here, and this one is array of n minus 1. Once again we are making the function call. Now the n will be reduced here 3. So that is it will be calling the passing the number from 3 to 6. So here the array 3 will be maintained, 4 will be retained as it is. This is the function, expanded function of the recursive call. And for this array 2, so function array of 2 plus array of 2. So here the 2, how it comes? So function array of n minus 1 is 3 minus 1 is 2. So then array of 3 minus 1 is 2 plus these value will be kept as it is. Once again, for this 2, array of 1 plus array of 1, how it comes? So array function, array of n minus 1 is 1 plus array of 2 minus 1 is 1. Once again, these values will be following as it is. Here array of 0. So now comes the condition will get, the stopping condition will get executed. So if n is less than or equal to 0 means it will return the value 0. So it is now, it is equal to 0. So it returns, since it is 0 mean it will return the value of 0. So here the 0 will get substituted. The value of array 1 is, array of 0 is 1. So 1 gets substituted. Here the array of 1 is, the array of 1 is 2, 2 gets substituted, array of 2 is 3, 3 gets substituted, like this it substitute, we will get the answer 21. So this is how the array function is being executed. So next question, the gate question. So here this is the function question given. So they have given the misery, they are passing an integer value n. Here in this function they are passing the value of 13 here and they are making the checking condition here, this much number of checking condition. If the value of n is equal to 0 means it will return 0. If it is modulus 2, that is if it is an even number means it is, we are just returning, we are dividing the value by 2 and we are just calling the function again. If it is an odd number means we are adding the number by 1. So actually this function will count the number of ones in the binary representation of an integer number. So that is what the problem. Here we will find the solution. So for this, the binary representation, the number of 1 is, actually the answer should be 3. Okay, so here we have the misery of 13. So this is the code. Here it will check whether n, what is the value of n? It is 13. If n is equal to 0, it is not equal to 0. So it will enter inside the next condition. Now it will check if n modulus 2 is 0. Here n modulus 2 is 0. No. So what it will do? It will move to the next condition, else condition. Here, so it returns, since it is not equal to 0, it returns 1 plus misery of n by 2. So what is n by 2? Since the value is an integer value, it will just truncate the floating point value and it will be returning back only the integer value alone. So the 13 by 2 is 6.5. So which will be, the 0.5 will get truncated. It will be calling the function by passing the value of n as 6. Now the 6 is an even number, since it will be checking 6 is not equal to 0 there. Next it will check whether 6 modulus 2 is equal to 0. Yes. So what it will do? It will return misery of n by 2, 6 by 2, which is 3. So once again it will be calling the function. So now it will check whether 3 is odd. So we are passing the value of 3 here. It will check whether n is equal to 0. No, it is not equal to 0. So it will check the next condition, n percentage, that is the modulus 2 is equal to 0. It is not equal to 0. Since it is an odd number, it will add 1 with it and it will be pausing, it will be checking mass, it will be once again calling the function misery of 1. So if whether the misery of 1 is odd, so here once again we are pausing whether we are checking n is equal to 0. Yes, no, here it is not equal to 0. So what it will do, it will move to the next else condition. The else condition is n modulus 2 divided by 2 is equal, n modulus 2 is equal to 0. What check, it will check and it will be checking. So it is not equal to 0. So it will return 1 plus misery of n by 2. So 1 by 2 is 0.5. So 0.5 gets truncated. It will call the function misery of 0, which is misery of 0 will be 0. So now n value is 0. So it returns 0 here. 0 gets added here. It is 1 plus 0, 1 Once again it will be moving back. Since it follows the stack architecture, it moves backward to find the solution. Here the 0 gets substituted here. 1 plus 0 is 1. 1 will be passed here. So here mystery of 1 value is 1. 1 plus 1, so which is 2. So once again it will be passing 2 as the result of mystery of 3. So here it will get replaced with the 3. So replace the mystery of 3 as 2, and here it will be the mystery of 6 is 2. So 1 plus 2 is 3. So the number of ones in the binary representation of 13 is 3. So this is what the output of this program, and this is what the result of this program. Okay, so here, so that's all about this gate session. Thank you. So we will continue in the next video.